Hi, welcome to this fourth session about live programming in order to analyze location coming from your phone, especially your Google account. Please allow me a minute. I'm going to first try to configure this, which is not the easiest part, and I have to admit that I failed last time. So I'm here trying again, and if this doesn't work, I'm not going to try for like half an hour like last time. I'm just going to be faster and cut it, record whatever is on the screen, and make it happen. So I'm first getting my stream key, putting it in my streaming software. It's called OBS, and it so far doesn't work. And yeah, now I'm gonna start streaming and check if it works. Does not. I'm gonna click edit here. No, not there. I just don't want to enter the same kind of nightmare I was in last time. So if this doesn't work, I'm just gonna switch directly to recording the thing. So let's try to cut the. I have some other browser tab that I'm gonna cut, and if this doesn't work, I'm gonna just record it again and upload it after, like I did before. So does the streaming work now? Streaming's ongoing. I see the upload. Okay, cool. So now, give me a second. Just gonna post a link to this on a couple websites. Just if someone wants to watch, I will be able to share this. It should take not more than a couple of minutes, so just be patient and it's gonna be okay. Okay, so that's the first website, and I'm going to post it on Reddit, something on Facebook, and we go. So that's actually I should try to post something better than this link. Okay, so the post on Reddit is done, and in a few seconds the post on Facebook will be done. Ooh, I'm not logged in Facebook. La la. Okay, doesn't matter. I'm gonna deal with this. Okay, so let's start. We can close this, delete. So the goal of this project is to analyze users' location history in order to detect when they cross paths. So as you know, it's suddenly super trendy to be in quarantine or in lockdown, depending on how you call it. Here, by the way, happy Easter to everybody watching it and being some kind of Easter people. So the idea behind that is to say that when you have disease spreading, it's usually convenient to be able to identify what is the source. I have absolutely no scientific background behind that, but my opinion was that the source, like finding where it comes from, can also be easier to identify how different sick people have met before, in order maybe to reconstruct all the path that the virus has taken. So that's these first words were about this. If you are curious to get your data from Google, from your account, you can go to takeout.google.com, and you only want to get your location data, because like basically this website enables you to extract every single data point that you have in Google. Just wait, I'm looking for a pen. I don't have my pen. That's very disturbing. I'm gonna survive with this one. So if you want your data, you can get it there from Google, and that's what I did. And you can see how we explore this data in the first live stream, which happened on the 22nd of March, where we set up the project and did some first simulation code, because I wasn't really comfortable in working with my own data and some like live programming thing. Plus, we need like more than one person data, so why not simulating this first? The second session was about unit testing this first simulation code, finding a few bugs, generating realistic daily trips, and again, like the whole code that you may need is already available in this GitHub project. And the third session was about writing our fake data in JSON files and loading them in another part of the project, which is like independent from the simulation, and we are going to see right now what we actually achieved from this. So here I'm just in some version of the project that's been checked out, and I'm gonna start first. Activate my virtual environment, then run Jupyter. Ta-da! And here we are. Look, we want this here and here. So that's what we did last time. So what we did last time was giving us this. So we are going to restart the kernel. Yes, okay, and we are going to run it. And we have a map. We have like marker. We're going to zoom out a bit. So this map is centered in Luxembourg because I am in Luxembourg, and we can see like a person itinerary there. Okay, so they move during, I don't know how many days this is. I think it's a single day, because the person is supposed to go back home after one day, and the beginning and the end are the same. So it's a single day. Okay, so now what we would like to, the first thing that we want to do here is to be able to visualize multiple person data. I'm just like checking my my to-do list. So yeah, that's I've done the project scope. I've been through what we have done so far, and now we are working on displaying multiple markers in order to visualize multiple persons data. So I'm gonna actually like, it's gonna be easier. Okay, so here in location data, whoa, I can see that I have about 40 persons. It would be nice to see all of them. So I'm gonna update on my thing to be able to get access to some persons data. So I'm gonna close everything. And so we can just navigate to the right element. So it's in location loader, and this location loader is basically opening a single location history, and then it's returning this location history. We are going to be a bit smarter than that. We are going to create a directory called model that's going to contain all our models, and we are going to have a model for person, Python package, and we're going to call that model, person. It's going to be fine. And here, just to be sure that we are compliant with the usual like Python package hierarchy, we are just going to create an init.py here. So here we are going to create a person. And we are going to create a constructor for this person. So this person has first name, which will be a string, and then it will have a list of locations, which are basically coordinates that we get for this person. So here we just initialize a private they don't need to be private, so name and location. We are going to keep this because what we want ideally is to then enhance this class and adding some extra thing in order for our algorithm, which will try to detect the different crossing between multiple persons. We are then gonna add a few properties here to be able to work with it in an easier way. So then we are gonna modify our location loader to call it a person loader. So here we go, person loader, lovely. Load, let's call it persons. This is going to return every person that we have in our system. And this, I don't know what this is. Okay, yeah, it is to get location. Yeah, okay. So this is gonna work with a person and not with locations, and we are gonna work with person.locations every time, and this way we have something which is already like compliant with what we want to have. So first, what we want to do is to be able to list every single person that we have there. So that's fine. We are gonna call this like person. Root directory is equal to this. Then we are gonna import OS. I think it's os.pass.lists. No, there. List there. Okay, that should work. This there should give me a list of different files in a path. So I'm gonna just print root.os.list there, here, and see what happens. So just to be sure that we are seeing some stuff, I'm just gonna copy what we have here. Yeah, I'm just gonna wanna like, how do we recognize that we are actually like running this file and not importing it from somewhere? So if we are in the main file, so we run the load persons function, and this should print the list of the different things. And this should not even create an error, so that's perfect. So now we do Python, src, locakes, person loader, and yeah, init. Ta-da! And it works. Okay, so it gives me exactly what I want. So I'm just gonna target pass dot, no, not this, sub directories. Okay. Can I filter them? No. Well, that's fine. We are just gonna do this like this. So this is equal to F standing for file in this, F for file in this, if person, because we know that all of our names are prefixed with person. So if person in os dot in F. This should work as well, and we print some directories, and this should work again. and it's just like to be safe. Okay, see, it works. That's perfect. So now we just create an array. And we create a private function called person, which take a path, like a target path, which will exactly look like this. Should it? Yeah, that's gonna be fine. So we are just gonna create a name, which is os.path.base name of target path. That's gonna be our name. And name.replace.json by nothing. I don't know if it's Python, if in Python replace is actually replacing inside the string, but I think that Python strings are immutable, so I would say that replace is returning a new string. How do we test this? We just create a string, which will be like Alabama, and we call it a.replace a with b. Yeah, okay, so it's returned. So I just need to do this. So with target path, we are loading the JSON, we are creating a person. No, we don't create person yet. And this is going to be our locations here. Return from locates dot model import dot model dot person import person. I'm gonna switch this to be uppercase. Oh well, that was brilliant. Okay, so from model dot person import person, and then we return a new person with a name and some locations. And so for every can we do this? We are just gonna do it the old way, right? So for sub, can I have some helper here for stuff? No, I don't. Okay, fine. For subdirectory, in subdirectories, then I create a target path, which is equal to this plus plus. We could also use os.path, actually. That would be that would make us more reasonable person. We are going to do it. Subdirectory, and here we are. Location history, JSON path. That's going to be perfect. We don't need a semicolon here because it's Python. And then we are just gonna go for person dot what person append load person target path. Why is it yellow? Path is not callable. Yeah, the join. Now it is. Okay, and here we just return persons. So now we just need to test what happens here. So we just print load persons. Here we are. Okay, so it returns some person instances. So I can implement this as str function, which I think is gonna make this a bit more readable. I think, nobody's sure here. And let's try again. No, it's terrible. Why isn't it working? Okay, it's not a big deal. So now we know that we have a list of persons returned from the load person function. So we go back here to this code, and we are going to add many markers. So here, from person loader, we use the get load persons function. So here we just load them, and we have our persons. And here, so we create like this reference point is created out of nowhere. That's fine. We don't care much, but we can do better. We create a marker array. Markers equal this. Marker is actually equal for. So we create a marker for reference point A. Can we try something wide like person dot locations at 0? Can we do this? Can we do this? No, we can't, because we need to use get location at timestamp. What is our first timestamp? It's right here. So it's the first person that we have. That's dirty, right? But we don't care much. The first person that we have at the first timestamp that we have, and the first person that we have at all. And actually it's gonna be less dirty if I do it this properly. So I initialize this empty array, and then for person in persons, I'm gonna create a marker. I'm gonna get a relevant location, which will be equal to get location at timestamp of, so I don't know the arguments there, which is timestamp, whoa, person? Yeah, it is this. Why too many blank lines? Okay, that's fine. Sorry? So at my minimum timestamp, and with a given person, I'm creating a new marker, which is equal to this. And then I'm doing two things. First, I'm adding this marker to the map. And then I'm storing these markers in my markers array. So that is great. So should be good. Here we are loading the locations. We don't need to do this anymore. And here, timestamp slider, we are creating our timestamp slider. When there is a new timestamp, if things are okay, timestamp equals, okay, so that's okay. Then for actually I can do something which would be very convenient, which will be to have this dot marker equal known. And so here what I can do is, instead of having this marker array, I'm just storing everything in the person dot marker equal marker. That's going to be much more convenient. And then for person in person, I'm getting the location at the specific timestamp of this person. And then the marker stored for this person gets its location updated. So yeah, okay, so what is different from what we had before? First, we now have one marker per person. and before we were displaying only the data of a single person. Now this marker is initialized at the first position available in our timestamp history. And that's it. And every time, of course, we update this slider, we get many markers updated. And let's test. Yup, that's obvious. Let's try again. Yeah, that's gorgeous. So we have all our people now, and nobody moves, and suddenly they all start to move at different points of the day. We can see then here that they are grouping, which is good because we defined points of interest such as, like, we made a limited number of them, so they only, like, we could increase the amount of people at the same spot. So this is working, this is great. So we see all our different people moving around. Let's try to be a bit wilder. Remove all location data thing. What is this doing? No, this is not working. So let's try. I remember that we have a generator accessible somewhere. So I'm just gonna try to launch it. There is no module named other thing. Oh yeah, I forgot to activate this. Damn, I shouldn't do that. Okay. So I don't know what's 10, 3, and 40. Oh yeah, it's the number of days. So we are just gonna try to do it to generate things from between 10 days ago and 9 days ago, so only a single day of data, but we are gonna try to generate it for 100%. Then if I list all my location data, I should now have about 100 files, which is perfect. Then I just reload my kernel, and ta-da! Now we have 100 points, which is cool. Really like this. So we have 100 points. They don't move in the morning. That's why here nothing is happening. And then suddenly we start to see them moving. They go to similar direction, and then they go away. They all go back home. So this screen exactly looks like these screens. Does it? Only slightly, actually. There are a few differences, which I don't really understand. We must have a tiny bug. No, it doesn't look the same. That's strange. It could be something to investigate, but somehow, right now it's not the target. So that is great. That's great. Do we see them grouping during the day? We should. I didn't want to move this. Okay, so that's the beginning of the day. Do we see them grouped? Not much. But somehow they may cross paths at some point. Okay, so first thing is, can we get smaller markers? So we are gonna look at the marker reference in HiPy leaflet. Yeah, we have it. Or we can also smaller marker HiPy leaflet. Draggable, by default it's true, so we are going to put this to false because we don't want this to be draggable. That's the first thing. So my marker here is draggable false. That's going to be easier. Then title, we don't want title. Rise over, we don't care. Opacity, visibility, offset. Icon. Okay, icon for the marker. Can I have a bit more information? Like, just a bit? Or not? Next. Icon. Yeah, well, that's fine. Great. Okay. Okay, fine. Can I find something here? I just need a dot. It's not gonna work. I don't want to host it anywhere. Where can I think about PNG file to use online? Can Imgur host PNG file? We can try. So we are going to use fa to PNG. Doesn't work. Just I don't have it. .io. Okay, fine. Doesn't work. Whoa, I'm suddenly sad. Can I try this? Yeah. Okay. No, it doesn't work. Okay. I just need a dot. Single dot. Yeah, these are cool things. Actually, I would need dots with colors. Can I PNG service dot with colors? PNG. So icon as a service with color. Can I have it somewhere? Services icon. No. See, that sucks. Okay, I'm gonna load it in smaller resolution. 24 pixel will be perfect. I'm not gonna attribute the author, but if you need, the author here is pixel perfect. Use this guy work. We are not gonna publish this anywhere. So yeah. So here we have a dot. So we go to imgur.com. Just want to see if I can hard link to Imgur. New post. Yeah. Please work. Please work. That's great. Copy image location. Can this work? Yeah. Can I hot link to this? Wow. That's gonna be gorgeous. Okay, so I'm gonna create a default icon. Let's try their sample code here. Let's just like copy paste it, everything. Okay, icon URL. So we are going to use whatever we put in Imgur. Sorry for the hot linking, that's bad. I absolutely 24 times 24. So we are going to just load it in 24 times 24, maybe less, 12 times 12. And to anchor it, I think anchor is the middle, it's supposed to be like where we want the dot to be. So we are going to put it in the middle, and we are just gonna try again. Restart, run. Well, that's obviously not working. Equal default icon. That's perfect. Okay. Stop, restart, run. Yeah, that's cool. Do they go any closer now? They seem to be rarely overlapping. for some reason I ignore. So let's look again in our location generator tool. Yeah, that's a terrible thing. I generate a new context every time. If I want my context to be reused, I need to keep it across the different generations. This way, because I think for example, right now every time that the location is generated with a different context. So yes, I have only 100 points of interest, but they are not the same for everyone. I need them to be the same for everyone. So I'm just gonna remove this again. Generate this again, restart my Jupyter kernel again, and run it again. And I should see more collision now. So here is our map. We zoom out. We just zoom out. Then the people are going to leave their house, and we see that they tend to group together much more than before, because here they are much more sparse. And here suddenly during the day they kind of group more together, which is somehow cool. Yeah, and we see also, yeah, points overlapping at some points. That's great. I still don't know why they don't hand their job. Oh yeah, they do. I just want to check if they are. So for example, here we have like 2 dots and 2 dots here and some kind of empty diagonal there. Do we have this in the evening? 2 dots, then empty diagonal. That's cool. Here we have like a pack of nodes here. And same thing. Okay, so they go back. Everybody's going home after the day. That's cool. So that's great. Now we are visualizing our multiple markers. Now what we want is like for every single we want to detect when persons are crossing paths and if they cross paths for long enough. Okay, so let's do this. So we have a person loader, and then we are going to create spread. Can we call this like spread analysis? Yeah, spread analysis. That's the name of a package name. So we are going to create a class for that. It's called spread analysis. And it's going to take a list of persons to begin with. Okay, cool. And it's going to also have some criteria. First criteria would be minimum distance for for spread, or spread minimum distance. It's going to be better. We are going to express it in kilometer, so we are going to say that it's in kilometer. So we want this to be less than 20 meters. Minimum time in seconds. So we say that this has to last for let's say at least 10 minutes. So 10 minutes is 600 seconds. Yeah. Okay. we're going to create a Python package here called location helper, in which we are going to insert this function called get location at timestamp. No, we are not going to do that. That's useless. We are just going to remove this. We are going to set it as a method here. Okay, and so here in our map, so we are just like replacing this function to use it as a kind of minimal timestamp. Like we make this function a method. That's nothing complicated. So here, yeah, okay. So this is red because we have too many line returns, but that's okay. And this we create another function called persons at range, which is an array. Should I do this? I don't know yet. Then I'm creating a function here called distance to person at timestamp. Okay. So I'm getting location 1. So location 1 will be equal to my own location. Location 2 will be equal to the other person location. I'm importing, so from housing, import housing, yeah. Just gonna check that this is the right thing. I think this housing function is used in our data persistence tool, if I'm correct. Yeah, cool. Yeah, it's right there. So yeah, it's exactly this. Cool. Okay, so now we want to iterate on every single timestamp. So we are just gonna create a function called timestamps to consider, which will be an array that we are gonna fit with get timestamp to consider. Maybe a mess would be nice. So yeah, that's good. So we're just gonna make a huge timestamps list. So if I do this, so for person in persons, for person dot for location in person dot locations, so I'm doing a two-level iteration, which here obviously doesn't work, and I don't blame anyone for making this not work, because this is shit. So we can't make this. Okay, so we're just gonna initialize an empty array, then we do for person in self.persons, for timestamp in, no, for location in self.persons.locations. Then we had the current, we append self.persons.locations, the timestamp in milliseconds divided by 1000. I'm just checking if this is how it works. Timestamp ms, not in ms. Okay. Then, ooh. Sorry. Okay. Sort array Python. Okay, this is listed sort. Let's check again. A equals 1, 2, 0, a.sort. A, so this is in place, so I don't need to reallocate this. So now I do this, timestamp.sort. And I'm gonna call this array like row timestamps. Basically, I'm gonna say that any events, I'm gonna cut my time in arrays of my spread minimum time, divided, maybe divided by 2. Because basically I don't want to process too many data points, too many different timestamps. So I'm just gonna sort this, then I'm gonna initialize my timestamps array, and then I'm gonna do something like for row timestamps in, just one last check if you don't mind. I just want to check that we are actually working in seconds here. That's perfect. So for row timestamp in this, so if, so let's call this delta. Delta is equal to row, to the current timestamp minus the last registered timestamp. Okay? But this might be empty. So if timestamp, we're going to initialize delta to known. If timestamps is longer than 1, longer or equal to 1, I can use this. If delta is not known and delta less than self.spread minimum time was set divided by 2. This way we kind of oversample, slightly oversample something that the phenomenon that we are trying to test. It's just we can basically just return the row timestamps if we want to have something exhaustive after removing the different entries that may be the same. For example, we can have like the same timestamp 10 times because we are processing 100% data. So if this timestamp is not known and lower than our threshold, we are going to call it time stamp delta threshold. and this can live outside of the loop. If this, then we continue, otherwise we add the current value that we are processing to our timestamp array. And then we return this timestamps thing. Yeah, okay. This is not bad, I think. So this array should now contain a list of the different timestamps that are relevant. Now there is a, we are going to create a function called detect crossings. So here, what do I want to do? For every timestamp, I want to check if a person is close to someone. So I'm going to create a structure in my person thing called crossings. It will contain crossing objects that we are going to specify more, and that this way we don't need this. So a crossing has a start timestamp, which just is an argument. Sorry, I'm sometimes hard to think and type at the same time. So it has a start timestamp, it has an end timestamp, which is known at the beginning, which is not an injected parameter, and then it has some persons that are involved. So when it's over, you can just you can call a get duration function, and then we can also have a valid attribute which will tell us, like, we are going to call it valid spread. So is this something where we can consider that the virus has spread? And I don't, whoa, console, what's the problem here? Okay, I'm just gonna do it this way. Otherwise it's looking everywhere in my code base if I wasn't using this variable, so it can take quite a bit of time, and I know that I will choose it because it's right here, and I just written this function name. So the duration is my end timestamp minus my start timestamp, and I'm returning the 2 here. Of course, if end timestamp is known, well, shit happens. And this is a bubbling function. So a person can have different crossings. And if the timestamp is known, it will be considered as unresolved. So, for timestamp in self.timestamps, I should rename this just to be timestamps. It would be 10 times easier to read. And I mean, it's obvious that those timestamps are the timestamps over which the analysis is happening. And in case of that, like timestamps over which the analysis is happening. Double P, yeah, okay, single M, yeah, cool. So update distances. Distance matrix between persons. This matrix should be what we can use. Since we don't care much about optimization, it's gonna be a matrix of integer indexed by string twice, and this string is the name of the persons. Here, can we also create something? Yeah, we can do this. Can we do this? I think we can do this for person in persons. We want to have person.main. Aren't we creating something more complicated here than what we need to do? Yeah, maybe. I'm just gonna keep this like this. Oh, so is there any distance relationship between strings in Python? So can I say that A is less than B? Yes. And then can I assume in that case that B is more than A? Yes. No. Okay. Okay. Other relationship between strings in Python. You know what? Let's do something else. Let's add another field in our persons. This field is going to be an ID, and this ID is going to be an integer, and it's going to help us to make things like more obvious. We will have an order relationship between our IDs. Everything's going to be perfect. It's shadow a built-in name. Okay, so we are going to just call it person ID. Okay, and in the person loader here, where do we create a new person? Here. Okay, fine. Person ID counter equals 0. We increment it here before anything, that's fine. So like now every person has an ID, and suddenly here we can deal with IDs. Identified by their IDs, and here we can make a cast to be integers. This way we are going to be good. So here we are updating our distance matrix. Let's go. So here in a person I have something to tell, like distance to person ID timestamp. Okay. So yeah, of course, this takes a specific timestamp. Timestamp. Okay. So I'm going to initialize this array. So for person in persons, self.distances person.id equals empty dictionary, and then self for two person in persons, blah 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 blah. Then I'm gonna do the same thing. First person ID, then two underscore person dot id equals 0. We are going to say -1. This way we know that this is uninitialized values. Just initializing these distances to be sure that the different keys are existing. Let's do a bit of math. Okay, so here basically we have like many persons that are spread everywhere. Okay, that is nice, but it is not as nice as we could think, because if we want to consider the distance from every entity to every other entity, we just like label them. So this is 1, this is 2, this is 3, dot dot dot, this is 1, this is 2, this is 3. The problem is that every time you had some new entity here, you are adding an extra person, and so basically the number of cells here is like if I have n persons. Wow, it's so cool to write with my trackpad. No, it's a nightmare, let's be honest. So here we have n square cells, and we need to do n square calculations. So for example, like here we have 100 persons, so it's 100 times 100. So if I'm correct, it's 10,000 calculations. It's actually 100 times 99, because like the distance between 1 and 1 here, we know it's always 0, and between 2 and 2 it's always 0. So it can grow quite fast, and the Hauer-Sinn formula is not easy to run every time, because like it's very complex, as we have seen in the previous video. So ideally, you don't necessarily want to do what we are going to do here, especially if you need to have some performance or a lot of entries in your database. What we could do, though, is to make a grid here. Then for every point, we just identify in which cell of the grid the point is, and then we only compute the distances with this point, with the cells which are here, here, like all the cells which are adjacent, like this. And we need just one single little thing, which is that this distance here, x needs to be equal to our minimum mean distance, the minimum distance that we want to know if 2 points are near or not. So why? Because if x is here, sorry, my point is here, plus x will lead here, so we need to have this cell too. It will lead here, here, to the squares again, but it won't go outside of these 9 things. And it means that if we have a huge map and a small search distance, this can limit or like computing the distance only between a handful of dots and not between all of them. And suddenly we can afford, like our matrix here, to have a lot of holes. And that would make it a bit more efficient. Actually, that's how I would make it if I needed to have it more performant. So here we are going to do a simple thing. We are going to iterate over each person. So person in self.persons for 2 person in self.persons. So if these 2 things are equal, if these 2 persons are equal, then we know that self.distances, let's do it otherwise. Let's do a, yeah, okay, fine. If person.id equals self.id, then we return 0. So now we do if person inferior person.id is less than self.person, sorry, then 2person.id. Why are we comparing id here? Because the distance which is between person 3 here, and person 1 here is exactly the same as the person from 3 the distance from the person from 3 here to the person here in 1. So we know that if we call the value here y, this value will be exactly the same as here. And so we only want to compute it once. So if this distance, like if we don't have this, well, then we know. Otherwise, we do self. So from person ID, we force compute the distance, which will be equal to person dot distance to person at timestamp 2% timestamp, which is the specific timestamp we are working on. Okay. And then we also do the opposite, which means we swap the IDs here. This way, like, we only compute the distance once, but our matrix is filled in the bug thing, which enable us to, like, kind of detect if something is like to not run distance computation twice, but still have both cells filled in here. And we're good. Okay, so now with this we should have a distance matrix, which is great. So we update the distance matrices, then we need to update the crossings. So now we need to update the crossings. How do we do this? That's a good question. I'm going to think about it right after, which means like right now. Couldn't we do it here? Yes, we could do it here. So can we? No, because here we are only computing one direction of things. So we update crossings at a specific timestamp to be sure at a specific timestamp. So we iterate again on every person. And now we want to, so we want key value iteration Python 3. Why is it so big? I just need a snippet. Just like, why is it so big? 2000, does it say Python 3 somewhere here? Yeah, okay, that's what I want, key value, okay. So, distances from this person, just to be sure, is self distances at person.id. Okay? No, I could do this. Sorry, I'm still thinking if I can do this in update distances or not. We don't care much, but We do care a bit. Do we care? I don't know. So my key here is my other person ID. Which is bad. I shouldn't do this like that. I need to do the exact same thing as here. We could do this in the same loop. We just don't, but we could. So my distance now is equal to self.distances okay. If that's like so, do I have a crossing? I have a crossing if my distance is less than my minimum distance. Okay? And then I tell to my person to consider crossing with this other person, and I'm going to do the other thing in the other direction. I'm going to maintain here a list of active crossings. Do we care about that? Yeah, why not? Why not? Why not? That's okay. So crossing here is a boolean. So here I'm going to do a single thing. If, hey, that's fine. We are just going to look up if we have an active crossing with this person. So for crossing, we are going to call this variable is crossing. Sorry, I should have used my ID features for renaming. So for crossing in self.activeCrossing. So here I'm maintaining a list of currently active crossings to not reiterate over all the crossings I've seen before. It's just another way to just like limit the amount of iteration that we are going to run on everything. I don't want, for example, when after 10 days of processing to analyze crossings that happens like 10 days ago. It doesn't make any sense. I want to look at crossings which are happening right now at the current timestamp. And actually, I need to add this to provide the timestamp there. Update crossing timestamp. So I have a problem here because my logic between like what defines an actual crossing is like the configuration is split between spread analysis and percent, which here is updating things, which kind of is strange. So I'm just gonna return the updated crossings here. And this function will then process every single crossing to decide whether or not it's valid. So the field here, valid for spread. And this way, this function will not care about the spread minimal time. So if I have an active crossing, I'm going to check if this crossing dot persons, yeah, oh shit. So so here in this crossing, I know that one of the crossing person will be the current object I'm implementing this function for, and the other one will be the target person. So if crossing person dot id equal crossing person dot id equal person, I know it's a crossing with the current person I'm processing, which is good. So actually, the case I want to let, yeah, no, ow, ouch, that is terrible. How can I solve this? I'm going to create here a function which says like def involves person, involves a person, and then for person crossing person, yeah, crossing person in self.persons, if crossing person dot id equal person dot id. I think I could also implement just a simple comparison here, but if this is the case, I'm just going to return true, I found it, otherwise I'm going to return false. And here, and then I just need to say if crossing dot involves, no, if crossing dot involves, yeah, person, if this crossing does not involve this person, then I'm going to continue, simply ignore it. Otherwise, I found a relevant crossing. That is great. So I'm gonna, yeah. So if is crossing, so this crossing is currently active because it's in my list of active crossing, and it's still ongoing at this specific timestamp. So then I don't need to do anything. So this crossing is active and should be. Actually, I'm going to do something else. I really hope that you can follow. So I'm going to create a function called get active crossing with person, and I'm going to just do this. So here I'm returning the crossing. And at the end, if I don't find anything, just to be obvious, I'm returning none. So it's either returning the current crossing or not returning anything. So now I'm just going to do active crossing equals self dot get what's mass tool, get active crossing with, something is wrong in my implementation. Oh yeah, it's that this indent that's not helping. Person. So now if active crossing is not known and is crossing, so I have an active crossing and the crossing is currently happening, then I don't do anything, I just return. Should I return a crossing? Yeah, I should return a crossing. Should I? Yeah. This way the calling function on the left side actually sees what's the, if like any active crossing is there. So now the other case is if active crossing is known and there is no crossing ongoing, nothing is and nothing should be. It's very dark, but you get the point. So here I know that now I am in a case where I should do something. So first case is like if is crossing. So then I have a crossing, but I don't, and I can deduce active crossing is currently known. So then I'm just going to create it. So active crossing equals, do we have a crossing here? No, I should import crossing. So from locates.model.crossing crossing, import crossing. Then I'm going to create a new crossing between two persons and a start timestamp. The start timestamp is right now. It's starting now because it's the first time I see them crossing path. And then I'm providing a person array, which is made of myself and the person I'm crossing path with. Well, myself is the person I'm currently writing this method for. So then I have a new crossing. Do I have everything felt here? Yeah, it feels like it. Just going to split between the things that's going to set after and the things that are okay. And then I can just return this active crossing. Wait, I need to add this crossing to my active crossings. And I also need to add this crossing to all the crossings that are registered for this specific person. Now, if not crossing, then I know that I have an active crossing, and it's over. So then this active crossing dot end timestamp should be set. And it should be equal to the current timestamp. Do I know now if the valid spread should be set to false or true? No, I don't, but I'm going to return this active crossing. So this function here can actually set it to true or false. Return active crossing. What should I do now? I should remove this item from the active crossing array. So self.activeCrossings.remove. Can I do this? I can remove an object like that? Wow, is it? A.remove 0. Can I? Wow, I want to do this. Thank you, Python. I saw it was harder. Okay, cool. So now I'm getting crossing. I'm getting two crossings. So then I'm creating a function here called mark crossing has valid spread. It takes a crossing as an argument. So if the crossing dot end timestamp is known, it means that the crossing has ended, and actually it's if it's not known. So if the crossing has not ended, then I'm returning, nothing to do. Otherwise, my crossing has a duration, so I can call a getDuration function, and if this duration is more than my minimum duration here, then I'm considering that my crossing is a valid spread. Hey, make it shorter. Yes, sir. Okay, this is more explicit like this. Okay, is it okay? Is it enabled? Yeah, by default it's false. That's good, that's good, that's good. So then I'm just gonna do like mark crossing as valid crossing, and then I'm gonna do the same thing here, and maybe I'm gonna create another variable because it's actually gonna contain another object, so I don't want it to be ambiguous, so I'm just gonna do it like this. And here a timestamp is to be provided as well. So I prefer to do it this way because this way the logic of who is deciding where crossing is valid for spread is everything is kept in this left file, which is called spread analysis. And all the rest here doesn't care much. It manipulates objects which doesn't maintain by themselves their own integrity, because it means that sometimes crossing can be like have an end timestamp, but you need to hope that the spread analysis module here is doing it properly in order to mark it as a valid spread. But still, I think it's better than having nothing. And to remove ambiguity, actually, valid spread should be set by default to none. Okay, so now for every timestamp, I need an S here. Why is 2% gray here? Yeah, because this is bad. Update crossing should be done here. I'm gonna do it like this. Update crossing person to person timestamp. This way we do it like this. And here, if found, we do this. Self person to person timestamp. Okay, this way we have like smaller functions. That's better. Wow! I'm thinking if we can like unit test this easily, we should. For sure, we should for sure. That's the way things should be done. So we're gonna try to write a quick unit test with this. I would prefer to visualize things, but yeah. I'm just rereading everything, but just to see if there is some magic mistakes that's popping to my face. But it doesn't seem that there is any. Yeah. Okay, I'm gonna create a test for spread analysis. So I'm gonna put in here new Python package. I'm gonna call it test underscore spread analysis. Ta-da! I'm gonna import locx from locx dot spread analysis dot that's it. Import spread analysis. Yeah, that's what I want. Then I'm gonna need persons for sure. The persons, yeah, import person. Okay, so test spread. We're going to call it like this. No, we're going to call it like this. No, how is it called? Detect crossings. Detect crossings. This naming could be enhanced, but it's not bad either. Crossings with an S. Okay. So I'm going to create a new spread analysis, which takes some persons as an arguments, and then I'm going to need to create this person's thing. Okay. So I'm going to create like fake location 1 equals. Damn, it's taking a lot of things. Do I really want to do that? Because it feels like it's a pain. It is a pain. Okay. Okay. Maps.google.lu, and we are gonna go to 12 Rue de la Viche. Here we are. Okay, welcome. That's where I want to be. Okay, that's fine. I want locations which are within this circle, and here we have the units. So this is like 50 meters. So if I take a location here and one here, they shouldn't cross paths. Now if I take a location here and one here, they should cross paths. So how do we fix this? First location, and we need to encode everything in this shitty format. So we are just gonna do this. That's what makes unit testing not so much fun. So timestamp in milliseconds. We are just gonna fake it. We are gonna start at 1,000. That's a very bad idea. We are gonna 100,000. Is it good? No, it's 1 million. Okay, that's fine. Let's make 1,000. That's good. We're gonna start at 0. That's better. We're gonna start at 0. Then we know that we are using values which are like latitude E7. So we are gonna use it latitude E7. So our first person is gonna start here to the left. My ability to copy paste coordinates is terrible. Okay, so that's latitude. And that is longitude. Let's say that this person is not moving. So we are just gonna like create couple timestamps, couple like fake location points. Damn, wow, that's gonna be boring to create this. I'm gonna create a function just for this. Def get fake locations. What's the matter here? Contains duplicate T. Oh yeah, sure. Longitude. Longitude here again. That's great. So we said that this person is not going to move. So we're going to say that after 20 extra seconds, we said that we want to work in a 10 minutes time frame, and I don't want to create like too many data points. So I'm going to create this first thing after like 1 minute. And with this way, that's not enough. We are going to create like after 3 minutes. 3 minutes should be this. Okay. They don't move. So even after like, that's 3 minutes is like our two occurrences, time, stamp, units, kind of scale. Yeah, I was going to call it scale. That's nice. That's perfect. Times 2, this way is after now, it's after some time, 3, 4, 5. So after 5, we will have like 3 times 5, it will be 15 minutes. After 6, it's going to be 18. 3, 4, 5, 6. Okay, so this guy is not moving. Too bad for him. I hope he's not dead. Okay, fake location number 2. We are going to put this person at the same starting point, but we are going to make them move, and they are going to move towards the 12th Rue d'Ollerich. Thank you. Can I have coordinates? So, okay, so if you click somewhere like too precise, they suddenly hate you. Can I do this? Yeah, okay, that's better. So this person starts at the same point, and then they move. That's the first position. The second position, that is the third. You know what's terrible here? I messed up with my units, so I need this to be. That's fine. I'm gonna be lazy. No, I'm not gonna be lazy. 1, 2, 3, 4, 5, 6, 7. Yeah, looks like you could shut the fuck up. Okay. Okay. No, not okay. Okay, okay. 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 Okay, okay, okay. Okay, okay, okay. Don't multiply the timestamps. Okay. This should be 6. Okay, we have an idea, we have a rough, do we have a rough idea about the units? Because it feels that, oh no, it's good, okay. I'm gonna change this, yes, okay. Please don't let me copy paste in my life. It's getting boring. Okay. Okay, we are getting close. The last person will be a static person. And yeah. Perfect. Then they are going to go there. And then I'm going to say that I'm like here. That's going to be gray. Not gray, but great. Okay. Great, we have it. So now we return fake location 1, fake location 2. We add a line return after this. We are just going to create another fake location called fake location 3. So basically what we are going to test is that we are going to, so we fake the person over there, right? About 200 meters brings us over here. And then we are going to put another person about here. Static, same thing, they won't move. They won't move. Fake location 3. We are going to position them here and here. Lovely. Okay, now just to twist the things a bit, I'm gonna just add like 20 to be sure that it's not like creating problems, because sometimes we have like some slides. We want to not oversample different points, and we just want to be sure that if we have different timestamps, it's not creating problems. And actually, I should use something more just to be sure that it's in the order of magnitude of not being ripped off when I remove all the milliseconds. and this too. This is 130. Yeah, it's about. Yeah, will it be about a minute? Will it be more than my scale? Yeah, it might be. No, it might not be. So that should be good. Okay. So basically, I have like one person here, one person that's going to go from here to here, like doing and one person staying here. The person moving is going from here to here. So they first should meet with the first fake location. And then the third person, right, should be the last one to meet with the second one. So we are going to test first that these two persons, 1 and 3, have only one crossing, that none of those crossings are valid because the person is not staying long enough, or maybe it is it? I don't know. I don't think so. We are going to test. And that they are not crossing with one another, and that person 2 has a crossing with both of them. Sorry for the mispronouncing. So I'm returning fake location 2, fake location 3, and that's going to be good. So my persons are actually distant persons. They have a name. I'm going to create a name, counter. Can I do something like that in Python? bn equals 1. b equals string of n plus equal 1. Yeah, it's an invalid thing. Okay, that's fine. So I'm going to create something called fake locations. For fake locations, in fake locations. Then I'm going to just create my empty array here. I'm going to create a name, counter. I'm going to initialize at 0. So name equals name counter plus person dash. It's going to be good. And then I'm going to create a new person with this name and just locate fake locations. Isn't it great? It seems great. So a person actually takes first person ID. Oh, that sucks. A name and the location. So the person ID here, it's going to be the name counter. That's going to be fine. Cool. That's great. So so now we have like faked a few persons for a unit test. We want to run the spread analysis of our these persons. Okay, and now we want to. So this is our first person. This person should have cross paths with only one person. So self dot person 0 dot crossings should have a length of 1. Sorry. Same thing for the last person we have, which is person 2. And for the person in the middle that is going from here to here, they should cross paths with the person here and with the person here. Okay, person 1, person 2, and this should be equal to 2, but I'm gonna like let it crash just to be sure that everything is good. So I'm removing like this extra lines, and I'm gonna try to run my unit tests. Something's wrong here. Something is wrong. Why? Oh yeah. No, it's just wrong. So my test should be prefixed by tests. Oh, because I've created this as a package. It shouldn't be a package. It shouldn't be a package. I should rename this as test spread analysis. Yeah. And I should move it up. Can I? Yeah. Okay. Need to remove this folder. It felt all too good. Update crossing is missing required positional arguments timestamp. So update crossing is called here. It must be called elsewhere. Obviously. Oh yeah, it's maybe this one. Yeah, of course it's there. It's just what we are going to fix this bug here as well. Which file is it? It's kday data short distance between points. Okay. Cool. Import random, print seed equal random dot random, print seed rand int. That's gonna be fine. Between 0 and 1337. That's gonna be like big enough. And again, you can go to the dark side. You Google the dark side Franz Mikoli, and you will have a good explanation about why we do this. But basically, the random number generator is generating random things, and our tests are statistically working, but not every time. So we are going to fix the seed, which will give fixed behavior to a random number generator, and so we won't have this random crash again. So random.seed, I hope it's a function, and I'm going to set it to seed. And if it works now, I'm just going to fix this seed. I think it's this thing, 644. So I'm going to just say seed is 644. And now it shouldn't crash anymore. Like this thing called in the location generator test shouldn't crash anymore. Okay, let's run it just to see if it crashes. Well, I think we're good. Yeah, for now we're good. But the others may crash as well, but for now we will just check this. So person object has no attribute get active crossing with. Oh ho, 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 ho. I'm pretty sure it does, but get active. Okay, yeah, fine. Let's kill the fun. Yeah, it works when it shouldn't work. That's great. Okay, that's strange. So it shouldn't work because this point here, wait, spread analysis, test location generator, test spread analysis, it's right here. So I'm going to print, like, this should be equals to 2. So the way to debug this would be to say print person 1 dot crossings to see how bad they look. I'm pretty sure it's going to look stupidly obvious. Yeah, okay, thank you. Thank you. Thank you, Sherlock. It's very useful. I have installed last time another package called pprint. I'm going to check if pprint can fix this display here. It's going to be easier. I would love it to do it. Model object is not callable. Yeah. Print object Python. Okay, fine. So we're just gonna say that crossings of persons once are here for crossing in crossings for person in crossing dot persons print person dot id. Okay, so everybody is crossing paths with person 0. That doesn't sound very smart. I'm gonna just check that all of my persons have a different ID, which may be okay. It's fucked up because my name counter here never increments when it should. Do I do it for my location loader, person ID counter plus equal? That's perfect. Non-type has no attribute and timestamp. That's a better error. So it's in spread analysis line 85. Okay, so this time here we can return known. So if known, we shouldn't update this crossing. If crossing is known, then bye-bye. Cool. Okay, so now I have too many crossings. It's better. I don't know why, but it's better. So I don't know how it happens, but it happens. So instead of testing this here, oh, it's for person 0. Okay, that's terrible. I think that people are crossing paths with themselves, which might be stupid. Just testing for person 1. If I have the same kind of behavior, like there, it's I should expect like 1, 1, 1 stuff. Yeah, 1, 1, 1, 1, 1, 1, 0. Okay, that is stupid. Okay, so test location generator. It's not there. It should be in spread analysis. Update crossings. So I update distances, then I update crossings. And here I should say if it's inferior or equal, which should like process also exclude like self-matching, then it should work. Lovely. That is lovely. So we have a problem because like person 1 doesn't seem to be crossing path with person 2 because they actually have a single crossing, but person 2 is actually only crossing path with nobody, which is like consistent. I'm not saying it's perfect, but I'm saying it's consistent. So okay. If person.id equals 1 equals 2, because I ignore if it's equal to 1. So I'm only looking from the second person perspective. So if this, then if 2 person equals 1 dot id, sorry, then print self print distance. That's fine as well. Yeah. Yeah, because I'm bad. Yeah, obviously, because I'm missing 200 meters, and yeah, I am. Yeah, so this is happening. Why? Because the distance specified here is not 200 meters, but 20 meters. So I need the last position of person 1 to actually be more or less equal to the position of person 2, and not as far as I set it first. So I can fake, I'm going to fake the location of person 2 to be the last one of person 1, and it's going to fix the problem. With some difference, because I don't want this to be perfectly matching, so I'm going to say that this is like 8, and this is like 8 as well. I think it's a small distance difference. We're just going to test if it works. I'm pretty sure it's very small. Maybe not 20 meters, so I'm going to just set it for the... That's fine. Was willing to use these coordinates. Okay. And I'm going to set this to 5 and this to 10 extra, and then again run unit test again. Why? Why? Because the distance is still too big. Okay, starting again with the original value, which is this one, and I'm going to say that this is 2 and this is 2, 2, and this should work. Great! No, not great. This distance now is 80 meters. Why is it 80 meters? Oh, because there is also the frequency at which I'm checking things. So I should maybe make this person stays longer at some point. So I'm gonna have some okay, so 6, 7, 8, 9. So this bug was happening because actually, like, I'm not always analyzing the different locations. So there are gaps during which I'm not looking at the data to try to have like less consume resources, and that's why that's the problem we're having. So I've had it until time scale times 9, so I have like 10 time scale points. I'm gonna just like make this person stays there. So 6, 7, 8, 9. We are gonna last a bit longer. So I'm gonna add something here still to test with my timing problem, like to be sure that the time difference is not causing problems. So 6, 7, 8, and 9. Let's start again. Invalid syntax. That's lovely. That's a new problem. Where is it? It's right here. Could you wait a second? Just Okay, this doesn't sound too bad, except that this looks like a crossing between the same persons twice. I'm going to investigate this later. But person 1 has a crossing, has 2 crossings. That's normal, that's what we expected at the beginning. So that's a good thing. Let's scroll back to this. So person 1 is declared there, and we have something this here. I'm gonna keep this here because I need to investigate. It feels that some crossing detection is not accurate, like exactly what we want. And then I'm gonna check if the execution is also good for person 2, and then we are gonna check if person 1 has the elements that we expect. So first, like, everything's okay, so that's good. Then I am printing for every person in crossing persons the person ID. So it means that person 1 is crossing paths with person 0, that is great, but then it's also crossing paths with person 1, which is stupid. It should be crossing paths with person 2. I'm gonna investigate also the crossing of person 2, just to see if they are also crossing paths with the... No, that's good. So I would say that the problem comes when I am inserting two things, the same thing twice. Yeah, because here I'm saying to the person to consider crossing with 2 persons, and then I'm saying to the other person to consider crossing with themselves, which is fucking everything up. Let's call a cat a cat. It's very French saying. Don't use it. We don't need this anymore because this is debugged. We just want to check now that the crossing of person 1 are actually good ones. And yes, so now person 1 is crossing paths with person 0 and also with person 2. That's great. Okay, and are those crossing valids? Is any of them valid? If any should be valid, it should be the last one, because like person 1 is going first. It's starting alone with person 0, but it's moving away as soon as the simulation starts, but it stays longer with person 2. So the first crossing should be false, and the second one should be true. Like the one should be valid, and the first one shouldn't be, and the second one should be. False and known. So the false one is not valid indeed, and the second one is shit. Yeah, because it has not ended, of course. So now I need to force my crossings to end, which is easy. Once I'm done simulating for every timestamp, I'm gonna fake every distance to be super big, so to be like more than whatever is needed to consider a crossing. So times 2, for example. We do this to force the crossing analysis. It's not good. We do this to force the crossing analysis to mark valid spread. We need to end every crossing for this process to happen. That's cool. Okay, great. Cool. So now I just say self.update crossings at my last process timestamp plus, I don't know, 60 seconds, which is 1 minute, as you may know. If you don't, well, don't blame me for that. 1 minute. What's wrong with this? Oh yeah, I'm heading, I want the last value, not to add an array to some stuff. And then, ta-da! No, not so the last crossing here may not have lasted long enough. Let's check. Maybe I say if 1 minute is enough of contact. Let's check what's happening. So the first crossing is good and the other is not good. So I want here my crossing duration. So I'm just checking if it's my end duration minus my start duration. And if it is superior to the minimum spread duration, then it's a valid spread. Actually, yeah. Could I skip this variable? No, it's good. So, okay, I'm going to add a unit test to this. So person 1 crossings, and then I want this crossing with person 2 should be the last one. And it should be valid. Let's run this, it should fail. It's failing because I'm asserting something as false. Now I need to investigate why. Where is it? Okay, spread analysis is there. So, if crossing dot person dot persons, so okay, for person in this, if one person is person 2, then I want to print crossing dot get duration. Makes sense. Well, it doesn't make sense, but that's where I think I should debug something. Oh, the duration is negative. Why? So my end timestamp here is bigger than my start timestamp. That is strange. I'm just gonna check that my timestamps are actually set in the right order, but I think they are. They actually seem to be pretty much in the right order. What is happening here? Actually, they seem to be in the right order, but they seem to be, the sampling should be this divided by 2 and not times 2. Minimum duration divided by 2. Oh yeah, it's delta threshold. Oh, okay, that's okay. Fine. And here I'm asking for here. Well, let's do something else. Crossing dot start timestamp. Crossing dot end timestamp. This should be in the right order, but I'm pretty sure it won't be. But we need to investigate why. So it starts at this timestamp and it finishes at 240, which is not even in the process timestamp. I think I know why. Here, oh yeah, I should have taken -1. Thank you, genius. Thank you. Now it's working. Everything's fine. So now we have something that okay, that's cool. So we don't need to print this anymore. This was for debugging. That's great. Do we still have print statements here? Yes, we do. We don't need this anymore. Okay, great. Can we have something clean? Okay, cool. Git new git status dash s. Yeah, that's just what you did. Git add locx model. Yeah, git add src locx spread analysis. Cool. Cool, great. Now, what do we want to test? I want to test that like this render here is still the same. No, it's not. Not at all. Everything's broken. Okay, get location at timestamp. He has been made available in. It's not in the person loader. No. It should be there. Okay. Yeah, because I only updated this. I didn't update. No, I shouldn't. Okay. Oh yeah. It's still imported here. I don't need that. Run again. Should it work? Yeah. Okay, that's great. So I still have my points. Now what I want is to display all those people differently if they have been touched by a valid spread or not. So then I'm gonna do the following. I'm going to create a new function here called as valid spread at timestamp. If so, I'm going to use a different icon. So here I'm returning think for self.crossings. For crossing has self.crossings, sorry, it's in. If crossing dot valid spread. So if it's not a valid spread, we just continue. Is this valid in Python? Yes, okay. Yeah, but okay, known is false. That's perfect. So if this is known, okay, that's perfect. And then if crossing dot start timestamp is bigger, is smaller than the current timestamp, so this person has been like a part of a valid spread. It has been kind of infected if we are modelizing some kind of disease spread. Then we return true. Otherwise, we coordinately choose to return false. Then we go here, and we are just gonna need to import our spread analysis. So from locx, we just have the statement in the test. That's gonna be easier. This we don't use. Can suppress. Oh yeah, I was initially just waiting to test that everything was working, but that's fine. Okay, so we have our persons here, and then we import our spread analysis. So spread analysis, we are going to create a spread analyzer from persons, and then we are going to call spread analysis dot I think it's called detect crossings. Yes, detect crossings. It could be very slow. I don't think it will be because it's not that many entries. I think it should be okay. I think it should be okay. we're just going to try to run this. Restart the kernel, yes. Run, can take a while. It takes a while. We wait. We have absolutely no idea about when this will return. That's the joy of computer science. Please ask Alan Turing. Okay, so it could be smart to make a small way to test this. Okay, so here we are just gonna do our classic main thing. Is it working? No, it's not working. So it may be very long because I have too many people. So we are just going to try to get an idea about how fast or slow it is. Right now it's consuming a lot of processing power on my computer. Okay, so from locax dot person loader import get load persons. Okay. So then I'm saying that persons are equal to load persons. Still checking that, no, still not loaded. So if persons, no, not this. Then I want to create a new spread analysis, which is equal to spread analysis. No, sorry, to spread analysis of persons. Then I'm gonna do self dot spread analysis dot detect crossings, correct. And I simply want to make this a bit more verbose, which means like print. I'm gonna do can I do this? I would like to get the timestamps index of timestamp. Current index equals this. So actually I need to have like progression. Progression is equal to this. Oh, it's done now. Okay, great, 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 that's cool. So it takes time, but it works. Nice, that's what I want. So instead of doing this here, I'm just still gonna compute this self dot underscore timestamps print progression equals none. Okay, so if you want to think about how to optimize this, please remember switch back in the video to where I was explaining that you can consider your map as a grid. All the different points are on this grid. You want this grid to have a cell width equal to your minimal distance. This way, every time you update the position, you put every different person or points in a different cell. And you only compute, for example, if I'm concerned regarding this point here in blue, you only compute different cells where you have like red circles. So you take only the adjacent cells. This way you are, and if any point is outside of this, you know that it's further than the min distance from any point in the circle where you have the cell where you have the blue circle, which means that you can skip a lot of different points. But we are not going to do this just like because it takes more time and it's not the point. It's a quick hacking thing. So here we have a red dot. That's cool. You know what's better than a red dot? I'm going to tell you. It's a blue dot. Yeah, of course. Thank you, genius. So, adjustor, saturation, tint. Doesn't work much. Why isn't it working? Okay, maybe it's my understanding of this tint value that's strange, but let's boost the saturation and try again. It seems to only change the center. Okay, so instead of having a blue dot, we're just gonna have a, yeah, green. Green is fine. Green is fine. Green is perfect. Okay, so we are having a green dot. So I rename blue to green. I'm uploading this again to Imgur. I don't know how long they kept this, and again I thank them for just it's not really mature. Copy image location. Okay, still working. So we are going to do this hot linking thing again, which is not good practice, but it's still a fun practice, a convenient practice here. So our default icon will use this green thing. So we are going to rename like spreaded icon equal icon. So this is my green. I need to not forget this. So this is green. Spreaded icon is red, and now I want my default icon to be this. And now every time I'm updating this, I'm gonna say if person dot as valid spread at timestamp. So if this person has been enriched, if there is by any other person that could have been infected at a specific timestamp, which is my current timestamp, then I'm gonna do person.marker.icon equal spreaded icon. I'm gonna call it like valid spread icon, just to maintain like a consistent vocabulary across the different things that we are doing. So now I am restarting this, clearing the output. Yes, restarting everything. And now we just wait. And while this is loading, actually I think it could be interesting to discuss a bit about how we can, what could be the way to enhance this small system. That's not what I want to do. I want to move. I need to use the end. Yeah, okay. So I need a clean whiteboard. So the first thing is that we are using in our system point of interest, which means that we try to create artificially in our simulation places where people are gonna go often, like workplaces, restaurants, and things. The problem is that if you visualize what's the frequency that you will that people will attend to places, so it will be like number of that's bad. Wait, eraser. Yeah, okay. That's gonna be here. Number of people having this place in their center of interest here, and so the higher the more. Is it what I wanna represent? No. No, I want this to be, how can I move this pointer? Can I move this piece? I think I can move this piece. No, how can I move this? Select? Yeah, okay. So that's the number of people having this place in their center of interest. And that is the number of places, please understand, with that amount of people having this place in their amount of interest. So this curve here should look like a normal distribution according to what I've modelized right now. So sorry, let's stop here for a moment if you don't understand this. This means, for example, if I say that, so let's say that this is 10. Let's say that this is 20. Okay? So this representation means that we have 10 places which are having 20 people which are going there like every day. In our model, it's about every day. So, for example, if we go here, we would have like maybe about 21, 22 people, but we'll have less places having this. So we have a lot of places that are getting like this. That's the kind of distribution that we have. So we have a lot of places which are getting like the average number of people. The thing is that if you observe a distribution in real life, and I guess it's true if you observe a distribution with places, what you often observe is a power law. So you would have something that looks a bit like there's a very high number of people, okay, like number of people like this. It should look like this. So it takes me a lot of time to think about how to project it. It's not always, I don't know why, I don't feel it over intuitive right now. I'm just fixing my representation. So this means that here we are projecting the different people. And actually we have a lot of people having small interest and very few places having a lot of people. And this is called a power law. And our system right now doesn't modelize this, but a lot of things in the real world are following power laws. One of the ways to do this would be, for example, every time in our generation process, which is in the class called location generator, where we are getting random points of interest here. If a point of interest has already been selected somewhere, it should have higher chances to be returned again. This way, at the beginning, like every restaurant, every place start with the same probability of being in some person points of interest. And with time, like after the first iteration, there will be like 3 or 4 different places selected, and those places have a higher probability of being selected again. And if they are selected again, then we also again increase the probability. And this kind of generation will create something that looks like this kind of power law, where a lot of places don't have a lot of interested people, and some places have a lot of are in the same interest of many people. So it's kind of this kind of models is also called like rich get richer. Now, do we have this? No, not yet. Is it still running? I don't know. No, it is not. I didn't run this. Seriously? No, I didn't. Okay. Nice try. Okay, so that's the first thing that we can do. The second thing that could be done would be to force people to travel across streets. So again, we are going to move here. And right now, the way we generate our position is that we have this referential, that's our map, right? And we say people are here, 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 and here. Well, why are my points suddenly disappearing? Make bigger points. So I have 3 people right now. And I'm going to make like 3 points of interest thing. So basically what we do right now is that when Jack here wants to go to his point of interest here, he does this. When Johnny here wants to go, he does this. When Carol here wants to go, she does this. So everybody is kind of like walking in a street as if like the whole world is a street and there is no building that you can't go through, there is no forest that are inconvenient to walk through, there is no like common path. And actually in reality, a lot of people are using common path. So the way would be to fix this, and one easy way to fix it is to say that this person, they can't travel somewhere until they are on a street. So the first thing they need to do is actually to go on a street, and then to go at the closest point on a street to their target location and move to this. So I'm going to draw my streets in blue here. That's getting ugly. So one way of getting your street is not to implement something modelizing the street, is just, you know, that right now we have one position is equal to x coordinates plus, not plus, but y coordinate. Coordinates. Okay, yeah. So, and one solution to say is to say that if x coordinates at some precision, let's say 0.001 is equal to x underscore coordinates. Again, this is in floating numbers, so we shouldn't do this. So I'm gonna infer to some epsilon. And let's say that epsilon is equal to 0.0000001. I'm doing this because we are working in with floating numbers, and if you equal that x coordinate should be strictly equal to this, that's going to be strange. Because you may have some cases where the divisions are not going exactly wrong and you have problems, and we don't exactly want that. So then we run here with y coordinates, also same test. And if these two conditions are okay, it means that we are on a street. And if not, well, the coordinates of the closest streets are equals to just rounding the y coordinate to this precision and the x coordinate to this precision. So by adjusting the target precision here, you adjust the size of your grid. And by forcing people which are not on a street to actually first go on a street until they are close to their point of interest, then you are forcing them to move only on a grid. And once they are on a street, you try to implement the way they move just to follow this axis. What does it change? And I'm going to take again my blue marker, and it changes that this person now, to go to this point, I think it was Jack now, I'm going to take another color, I'm going to take brown. Jack now needs to do this. Something like this seems kind of efficient. It's a very clean street system, not alike at all the ones that you have in Europe, but close to the ones that you can find in northern American places. John needs to do this, and Carol needs to do this. What does this change is that, for example, here, Carol and John are taking the same path, which means that they are more likely to cross path, which is more realistic towards what we are doing. And so this is the other improvements that you could improve here. The other thing is, as we discussed in the previous video or in the one before, you can update the, I'm going to find my words. Let me think. Yeah, you can force all those person to use the same speed. Right now, what we have is that what is fixed, what should be fixed, if you want to modelize person walking, is their walking speed. What is fixed in our system is the time that it takes. So for example, it takes exactly the same time for Carol to go from here to here in our current system than for example, Jenny, if Jenny starts here, which feels stupid and is stupid. So yeah, that's one thing. So this has run now. So now we have our map, and people are all starting like without having been touched by a spread, and then we are making them move. And they change in colors as when they are getting in contact with each other. And you see that the more the time goes on, the more reds appear. Ta-da! That's pretty cool. That is pretty cool. I'm streaming since 2 hours and what? 35 minutes, but I still want to do something pretty cool before going to other details. What I want to do something cool. So, and cool needs to be cool. So we are gonna initialize our population with 5% of infected persons. How do we do this? So we just had, we are gonna commit this first. Git commit -a-m session 4 modelizing disease spreading by analyzing crossings. Ta-da! This is done. We can push this. Now, I need to update my persons, and I'm gonna say if they are infected. By default, this is false. No, it's not false. Sorry, my brain is import random. Random.rand ends between 0 and 100. And if this is inferior to 5, so this gives us about 5% chances if I do this. Less than 5%, so inferior or equal, that would be, yeah, okay, that's great. Too many blank lines. Okay, so this person is infected. Yeah, okay. Now, I'm gonna mark my crossing as infectious. By default, they are not. Yes, by default they are false, but if one person is infectious, this crossing can be infectious. So for person in self dot persons, damn, that's gonna be cool. It took us like 4 sessions to reach that, but I'm really liking this. So if person dot is, how do we say it? Is the name? We're gonna call it is infected. Is infected. Yeah. So if person that is infected, feels like a zombie movie, then this is infectious. Is it English, or is it me like trying to? Yeah. Oh, can it be for a person? A disease liable to be likely to spread. Okay. Yeah, the crossing is infectious. That's that. We are going to call it this way, even if I don't know if it's proper English. So if a person is infected, then this crossing becomes infectious. Then, so similarly, we could like modelize in incubation time, but we are just not considered to modelize it. But it could work. It could be easy to do. starts, we're gonna do this. Does it starts infected? No, we are gonna make it simple. We can make it harder after. That's fine. So a person starts infected with a 5% chances probability. Okay. So now, the first thing we want to do is that when we create a person here, if they are infected, we are going to use the other icon. So if person dot is infected, then we switch the marker. Marker.icon equals valid spread icon. Okay. Okay, that's great. Now, we are going to say that this thing is a valid spread only if one of the two persons is infected. So it's a valid spread if this and my crossing dot infectious. We can say he's infectious. If person dot is infected and is infectious. Okay, fine. So now what I need to do is that if crossing dot valid spread. No, that's up. No. If I do this, then I need to mark every person from my crossing as being infectious. So for person in self.persons, no, in crossing.persons, person dot is infected equal true. Cool, that's great. So now, when a crossing happens, if at least one of the person is infected and the minimum duration is reached, and during the minimum distance is reached for the minimum duration, then suddenly the other person gets infected. So this way, we should be able to see a spread. 5% should be enough to have at least one infected person in our simulation. Because if not, if we don't have any, it's like we can compute the likelihood of not having any infected person there. Can we? Yes, we can. I'm always confused with this thing. Yeah, okay. So we are... so that's the likelihood to not... We have 0.5% chances of... 0.6% chances of having absolutely no infected person. We are going to take it. We are going to take it. I think we can deal with this. Okay. Then we are just gonna reset this, restart. Then we go here and we run. Okay, great. And it's running. Cool. So that was our, going back, it's running, so I'm going back to my optimization suggestions. So we said that traveling could be modelized across streets. We said that speed could be fixed. So that is great. Nevertheless, not many crossings will happen in the street. Because they won't be valid, because they won't match this minimum distance. That is pretty much normal and representing reality. To be more accurate, because transports and transportation systems and things like that are also I think spreading vectors, but to modelize them is hard, but maybe just adding more point of interest per persons would make sense. For example, instead of saying that 1,000 people are going to take the train every day, I'm going to add more a point of interest, and I'm going to consider some of them like being buses, and people are going to meet in buses instead of, and it's going to be considered a fixed place. So I think this simulation is not that bad. So now I have modelized this specific thing that's going to show us how the virus is spreading. Unfortunately, it's going to be on a single day. If we give it a bit more time, or if we implement the optimization described here, it could be much faster, much faster. And if we want to, like, we can actually compute here how much fast it could be. So let's do this here. It's going to be a cool thing to do. So right now we have like 100 person. So let's say that to process a single timestamp. So right now we have 100 people. Processing a single timestamp takes us 100 times 99 distance computation. Is this true? No, it's not. Divided by 2. Okay? So 100 times 99 divided by 2, it's about 5,000. It's about 5,000. Now, what we want to do is to say that this is our map. Okay, this is Jack. This is Mary. And this is Sandy. And what interests us is a very narrow vicinity around Jack. And so we are building our grid, so it's a huge grid like this. So it's like this. So it should be an equally spaced grid, right? So, and so right now we are putting people on a grid that is 6 times, that is, I don't know, what's the size of the grid? I think it's in the person location generator. We have a scale somewhere, I think. Minor delta. Yeah, okay, so we are working on a 20 kilometer span. That is 20 kilometers times 20 kilometers, and look up for matches on 0.02 kilometers radius. So the size of, let's call this let's call this square is our interest square. So our interest square is about 0.02 kilometers to the power of 2, which is equal to 0.02 power of 2. It's 0. Can I type? I would like to type here. I would like to edit this. Yeah, can I? Yeah, 0.0004 squared kilometers. So I'm mixing a 0. But our grid of 20 times 20, this grid is actually 20 times, yeah, it's 400. It's 400 square kilometers. So actually, I'm saying something stupid because it is. We said that this is the size of the smaller square inside. So this is 0.002 times 3, because I have like, if you remember properly, and if you don't, I'm going to show you. So I have like That's my scale, that's my radius, and I'm taking my radius once to the left, once to the right, once to the top, once to the bottom. So it's like 3 times this distance. So 0.002 times 3 to the power 2, it's actually 0.036. Can I type? Yeah, I should be able to do this if I do this. Okay. So any point has a likely probability, probability of being in this interest square of 0.0036 divided by 400. That is about not a lot. It's how many zeros are there? 5. Okay. That's 0.01%. So what does this mean? Now, let's say, and it's not true, but let's say for the sake of this analysis that I need to compute the distance to a couple, like putting this in the right cell, like my point here is in the right cell. Let's say that putting my point in the right cell is like computing 4 distances with other points, which, I mean, if it's wrong, but it's a maximum, because like you can 2 points, you get 3 points, and you already like kind of reconstruct a grid system. Here we just need to compare latitude and longitude, which is much simpler than heavily using the Haber-Seen formula that we have seen last time. So just to remember you, the Haber-Seen formula looks like maybe this is good. Is this a British website good? Yeah, it's a bit like that. It's a lot. It's a lot. And basically, if you are doing JavaScript, please don't use phi as a viable name. I don't even know how to type it. So yeah, it's not cool. So we have a strictly like higher bound to this. So now computing, like checking distances, takes first 4 distance measurements for 100 points. Okay, so that's 400 steps plus the intersection between the different points. To be honest, I don't know how to compute it, and I haven't thought about it before running this streaming thing, so I don't know. But we can say that it's about 99, like the probability to have at least one element to compare with would be 1 minus 0.001. So that's my probability of having another point in my interest circle to the power 99. Okay, so this probability here is the probability of having no other point in my interest square. Okay, and this is 1 minus so like the opposite of this event. So like the opposite of having no event is having at least 1. So this probability 0.01 to the power 99 I did do something stupid here. Yeah, okay. So the probability of not having one is 0.909, but it's in percentage. Actually, this is percentages. So if I need to go back, this is 1 minus 0, 0. This is, sorry, so just for everybody to follow. This value here is equal to 0.001. Maybe an extra one? Yeah, an extra one. Okay. So the probability of not having something in my same interest circle is 0.0 is this, minus 1. So probability of having something in my interest square, I take the complement, which is not having it. And so I am analyzing 0, so 1 minus 0.0001. Okay, to the power, so it's something very close to 1, to the power 99, and it's actually like still very close. So this likelihood here is close to 1%, to have at least 1. So this means that in 99% of the cases, it will be 0. So I will have much less interaction by this, and so it means that here the factor of comparison I'm doing is way less than what it used to be. So all those like things that were in the order of magnitude of 5,000 distance computations now will be in the order of magnitude of like 500. 500, yeah, in the order of magnitude. So this means that basically I have a factor of 10. But if tomorrow I'm comparing, like for example, with 10,000 people, suddenly this factor becomes much more. So my computations are now done. So here I see in red my infected points, and it feels that they are much more than 5% of them. Why? I don't know. I don't know. Why is it like that? Yeah, I know. I exactly know, because that's the infected person's... Okay. Start infected. If they start infected, I do this. Then I do this. Sorry, we will need to run this again. Because basically, when we are initializing the markers on the map, this spread analysis function has already run. But actually what I should do is not this. What I should do is just to keep my old code and just to update my visualization. Is infected. Yes, I'm going to keep this. I'm going to load my persons. I'm not going to run my spread analysis before I have first plugged my persons on the map, and then I'm running my spread analysis. That should be good. That should work. So we are again resetting everything, and we are going to relaunch everything. Run. Cool. This way it's gonna look better. So yeah. So now if we say, so just to give a cool complexity exercise, if we say that we have n people, right? So without optimization, we do n times n minus 1 distance computation, right? That is in the order of magnitude that we name of big O of n squared. That's not good. Well, actually, at least for that kind of algorithm, it's not good. But now, because it's, remember, it's n squared for every timestamp, so it's like you pay it a lot. With optimization, for every point, we run times 400, and then plus for 1% of points times 0.01, we run comparisons. But how many? That's the key questions. Well, the question is that if I say 3, it's going to be a lot. I have absolutely no demonstrations about that. How can I know the average? It's distribution. No, yeah. Bernoulli distribution calculator. I think it's this. I don't know. Stat track. Yeah, it sounds good. So probability of success of a single trial. We said 0.1. Number of trials. I'm gonna say 99, but I would like it to be n. But just I want to have a proportion about this. Number of successes. Probability of success of single trials. I don't know. That's what I want to know. Okay, that's not what I'm looking for. There must be some kind of distribution probability that simulates this. Actually, like, oh no, this does run. So basically, like, you want to know how much is the likelihood of, if you run a 1% experiment, no, you want to know on average how many intersections you are going to have here. I think so. And then you multiply it by this number of intersections that we are going to call I, and it's gonna give you something that will be in the order of magnitude of I don't know, because it's proportional to the size of your grid, but it's going to be much less than n squared. I don't have all the answers here, and I would need a pen and paper. So here we are doing this test again, and here I really hope that we have at least, yeah, we have 4 infected persons, which is what we should expect. And then this person are going to move during the day, and suddenly, at the end of the day, whoa. At the end of the day, we have 1, 2, 3, 4. Well, it's very easy actually. We 4 person in, so infected count, yeah, equals 0. 4 person in persons. If person that is infected, then I'm improving my infected counts. And then I'm displaying this infected count. And so my infected count is 23. So we start with about like 4% which are infected at the beginning, and we then have like 23 after only 1 day of our simulation. So here, if you want to then, like, you can use the simulation to simulate this. You can use this and replace with your own personal data and other people's data to see where you have cross-paths and to simulate the spreading of a disease. You can also say that suddenly I want all those people to enter in some kind of confinement or quarantine, and to limit their things to their strict obligations. So for example, you can force them to suddenly ignore in the location generator all their secondary points of interest, like this shouldn't be used. Same thing for the, like, if we take some extra point of interest, so like you can alter this function to see how the spread is different depending on the, how much different points of interest and social movements or different kind of movements that you have. And yeah, that's it. I'm gonna just commit this again. So first I'm gonna restart and clear output. That's great. Git diff. I just want to check that this IPython notebook analysis is not getting suddenly super big, but it is not. It's not. Okay. And are my unit tests still working? No, they are not, but I can fix them easily. They are not because like my persons are not infected, and so I want my first person to be infected, which we are gonna make. I'm gonna make only my person number 2 infected. So person 2, which is like my third person, but yeah, that is infected equals true, and then my unit test should work exactly the same. PyTest. Yeah, cool. And then I just want to update this, so I need to just go on YouTube. I just want to get a link to this video to insert it right now in the README file, and then I'm going to say some conclusion words. Okay. Okay. Wait a second. Wait a quick second. Okay. 4 sessions. So today we were the 12th of April 2020. Visualizing multiple person data, we made it. Maybe refactoring to keep things, maybe, yeah, so we did this. Algorithmic of people crossing paths, we did this. Discussion and final conclusion and discussion about potential, evolution, and optimizations. And I'm just gonna first grab a link to the last time presentation, which is there. Okay, this is updated, and I'm gonna grab a link to today's video, which is there. Okay. Okay, so trying to not use my personal aliases here. If you want to do like to kind of copy what I'm doing at home, I don't know. Simulates infectious disease spread plus edit final plus final edit, yeah, plus edit to final version of the README. Okay, git push. Okay, this is good. So should be updated. Yeah. So can I get this full screen, or maybe for a bit, just for the conclusion things? Yeah. Okay. So during this was a small social experiment for me. I was willing to try to like do some live programming session online. It was an epic fail for number 3, which I didn't manage to broadcast. But in any case, I said it was kind of interesting to force myself. It forces a lot of concentration because I'm not going on like reading things or oh suddenly I need to check this on Wikipedia. So I'm trying to stay to the point. I'm trying to explain what I'm doing. So it's kind of like in terms of brain power, it's consuming a lot. I have seen that a few people were watching it live. There have been a few views outside of the lives. So if you have any inputs about this, if you think that this media is interesting or not at all, I'm curious because it was more a social experiment for me than anything. And in any case, I wish you all a great evening, and also the best of things during this confinement and quarantine period, depending on where you are on the planet. And yeah, that's it. So goodbye, and maybe I will do this another time. Bye.